Hello everyone, good morning. Good morning, good morning. So today we are talking about sodium borohydride. I'm extremely sorry due to some technical issue. The live is started late. Okay. So don't worry, we will cover all the all the things about sodium borohydride NaBH4. Okay. So let's join everyone very fast. Everyone join. Okay, one by one for very fast. Okay. Good morning everyone. Good morning everyone. Am I audible? Please tell me once in the chat. Am I audible? Hello. Sir, please also explain on adding substituents on lithium aluminum hydride. Okay, we'll explain. We'll explain everything. Okay. Anything else? Good morning, Maharshi. So let's share this live and like the live as fast as you can. Okay. So we'll start within 2 and 3 minutes. Okay. Okay, thank you. Sorry for the late of this live started. Okay. So today we are talking about the topics covered in today's session. As you know, in yesterday I am talking about that we are unblocking your fear about the CSIR NET examination and busting all the myths about reagent. Okay, and as well as solving questions that are most important. Today we are solving questions that are most important about sodium borohydride. Now yesterday we are talking about lithium aluminum hydride. Okay, so we know that for any carbonyl compound, the lithium aluminum hydride transfers into alcohol. Okay, and for amide compound it transfers it into amine. Okay, and for nitrile it also convert it into amine. Now now one more thing, that is for there are two derivatives for lithium aluminum hydride, like lithium OET whole 3. Okay, no, lithium aluminum OTBU whole 3H. Okay, OTBU whole 3H, and as well as lithium aluminum OET whole 3H. These two are the derivatives of lithium aluminum hydride. Now if you see one thing, that in this reagent and in this reagent only one hydride is there. Only one hydride, it can accommodate to one hydride only. Okay, so because it can only accommodate to one hydride, it can reduce ketone aldehyde. Okay, it can reduce ketone and aldehyde easily. Okay, as well as it also reduce ketone and aldehyde, but there is a catch. Okay, so there is a catch, like when we wanted to reduce this, it takes two hydride, so it will not reduce. Okay, so it will not reduce by this. Okay, as well as not this. Similarly for acid, it will not reduce by this, not reduced by this. Okay, but for acid chloride, because it is very reactive, it will reduce, but it can only reduce to aldehyde. Why? Because when H minus attacks to this position, it will come over up and again down, and chlorine will leave the place. Okay, so it will like a substitution reaction. Okay, so similarly it can reduce acyl chloride, and H minus came here and chlorine leave, and we will get aldehyde instead of alcohol. Okay, so that's the thing. But there is now what's the difference between these two reagents? Now the thing is that it cannot reduce RCN, it cannot reduce RCN, okay, but it can reduce RCN to RC double bond OH, aldehyde. Okay, so see, it can reduce to aldehyde. Okay, understood? Everyone understood this? Hello? If 2 mole used for acid chloride, yes, after 2 mole, not, it's not 2 mole, it will be 2 equivalent. After that, if you use 1 equivalent again, it will reduce to alcohol. Okay, okay, what please, you understood? Okay, clear? So let's go further, that NaBH4. okay, now similarly like lithium aluminum hydride, there are something changed, something that counter ion changed and the metal is changed in sodium borohydride, like the counter ion changed to sodium and metal is changed to boron. Now what happened? Aluminum and boron are in same group. Now what happened in selectivity and what happened in reactivity? Now sodium borohydride is less reactive. Sodium borohydride is less reactive. Now why it is less reactive? Now why it is less reactive? Because the two factors are there. One is the metal is changed. Because the metal is changed, the electronegativity difference is lower and the nucleophilicity also lower, so the reactivity is taking lower, therefore the selectivity increases, as well as the counter ion is bigger. According to Fajon's rule, we know that the size factor matter, that is the polarizing power. We know that according to Fajon's rule, the polarizing power is directly proportional to charge and inversely proportional to size. So higher the polarizing power, the electrophilicity increases. Higher the polarizing power, the electrophilicity increases. But in this case, the sodium has the greater size, so the size increases, so the polarizing power is decreases. So therefore, when we go for carbonyl group, it will less polarize the carbonyl group then, and the electrophilicity of the carbonyl group decreases. Okay. Now we can produce NaBH4 in two process. In general, we can produce NaBH4 or we can synthesize NaBH4 in two process. So like the Brown-Selinger process, it is basically now it is commercially available, but it is basically provided in labs or something. We can make it our own. Okay, so if you use trimethyl borate in the presence of 4NaH, it will produce NaBH4 at 250 to 270 degrees centigrade, as well as if you use borax like Na2B4O7 in presence of sodium, hydrogen and silicon dioxide. Okay, silicon dioxide, so it will produce sodium borohydride. It is not important for your CSIR NET examination, but just to make it know that how it can be produced, it will I can show here. Okay, so you now about sodium borohydride reactivity. Most typically it is used in the laboratory for converting ketones and aldehyde to alcohol. See it for lithium aluminum hydride, it can reduce anything like so ketone, aldehyde, ester, acid, amide, it can reduce anything. But for sodium borohydride, it is most typically it is used to laboratory converting ketones and aldehydes only. Okay, so it efficiently reduce acyl chloride. It can also reduce acyl chloride because this acyl chloride is much more reactive than aldehyde and ketones. Okay, and anhydride also, alpha hydroxylactones, thioester, okay, thioesters and amines in room temperature or below. Okay, so it can reduce also this type of groups into alcohol or amides. Okay, but it reduces esters slowly and inefficiently. So remember, that is the sodium borohydride cannot reduce ester. Okay, it cannot reduce ester. That is its selectivity, or the reactivity does not allow to reduce reduce the ester. Okay, so with excess reagent and or elevated temperature, if you use excess reagent or elevated temperature, it can reduce ester. But in excess temperature or excess reagent, there must be some side product, or there must be some hazardous position for a compound we are handling with. Okay, now while carboxylic acid and amides are not reduced at all. So carboxylic acid, like this ester, we cannot reduce carboxylic acid, we cannot reduce amide, as well as this amide or carboxylic acid has not the criteria or has not the reactivity to towards NaBH4. Okay, so we know that in general we can say the reactivity order is like, we can say the first of carbonyl groups. You can say the carbonyl groups, once again, yeah, see the reactivity order is going through that the carbonyl group is chlorine, acyl chloride has the most reactivity, then we go for aldehyde, then we go for ketone, then we go for ester, then we go for acid, and finally amide. Okay, so this is the reactivity order. Now lithium aluminum hydride is so reactive, it can reduce everything, okay, but sodium borohydride can't. Okay, it can reduce only this and this. Okay, it can reduce only this and this. Okay, so similarly the mechanism is same as it is the lithium aluminum hydride. The mechanism for sodium borohydride is same as it is lithium borohydride. Okay, now say hydrogen bonding activation is required as no reduction occurs in aprotic solvent like digeslant. See, in lithium borohydride, what is the difference between lithium borohydride and sodium borohydride? Now lithium aluminum hydride, not borohydride, lithium aluminum hydride, we use aprotic solvent. Why? Because this hydride is so much reactive. This hydride is so much reactive, it will react with protic solvent and gives H2 gas. But for sodium borohydride, we need protic solvent. Why it happens? Because here we use boron. So when BH4 negative is not stabilized with H plus, it cannot reduce H minus. Okay, so hydrogen activation, see the hydrogen bonding activation required for is required. Okay, so we will use methanol or something, we would not use water, but methanol or something, protic solvents or something polar solvent in basically. Okay, so hydrogen activation required. Now for alpha beta unsaturated ketone, see this, for alpha beta unsaturated ketone, if we use lithium aluminum hydride on this, it will also reduce this, to this. That complete reduction occurs, like this double bond also reduce and this carbonyl group also reduce in presence of lithium aluminum hydride. But in presence of sodium borohydride, it is also reduced. The 100% product will be this. Okay, so everyone looking this live, please, everyone watching this live, please like the live and share to your friends. Okay, so this is the reaction. Now for 5-member ring, remember one thing. So for 5-member ring, 5-member alpha beta unsaturated ketone, this is okay for that. Now for 6-member ring, it will be different. But now one more thing, that if we use the reaction of NaBH4, if we use ketone or aldehyde using NaBH4 and H plus, it will give alcohol. For aldehyde, it will give 1 degree alcohol, and for ketone, it will give 2 degree alcohol. Okay, it will give 2 degree alcohol. Now for again For again, so the here we can see the mechanism is as same as lithium borohydride. Okay, so the first step is addition. The first step is addition. Hydride will added to the carbonyl group. Okay, next O negative happens, O negative, and it will O negative attach to BH3. Okay, so it will O negative attach to BH3. Again, hydride will happen, and four four compound four compounds, sorry, four almost, yeah, it will look alike. This one here will be hydrogen, here will be hydrogen, oxygen, and boron. So four moles of acetone will be reduced, and after protonation we will get this product. After protonation we will get this product. Now remember one thing, that this hydrogen comes for sodium borohydride, and this hydrogen comes for protonation, comes by protonation or workup, where we are using methanol or any acidic condition. This proton comes for any other side. So remember, if you use NaBD4 instead of NaBH4, so it will give like this product, OH, and here will be D, and here will be H. Okay, so it will gives like this product. Okay, everyone understood? If everyone understood, just give just type some share, just type some emojis in the chat box. Everyone, type some emojis in the chat box. Hello, hello, everyone. Okay, so that's the thing. Next for demercuration also we use NaBH4. The uses of NaBH4 for demercuration, we know there is a reaction called oxymercuration, demercuration. Okay, so we can use this for for what? Demercuration. In oxymercuration, what happens? There will be a reaction, that will be oxymercuration. The Hg plus, the mercuronium ion attached to this double bond, and after that H minus will attack to so no, after that H2 will attack to this, and H2 will attack to the most inert position, and we will get this. There will be OH, and there will be Hg plus. Okay, there will be Hg plus. After H minus came, and we will get this product. Okay, so what happened? The mechanism. So at first this mercuronium ion formed, and then water attached to this position, or the most inert position, more substituted position, and after that proton transfer. After that, from this H minus will transfer to it. Okay, so before going to that, some more things. Okay, before going to this, we'll go for some more things. Like we have already talked about the 5-membered alpha beta unsaturated ketone, this. But when it comes to 6-membered ring, see, when it comes to 6-membered ring, this one, okay, so it will give, in presence of NaBH4 in first step, and in second step H plus, it will give this OH plus this, the mixture of product, this. Okay, so it will give 56% of this and 44% of this. Okay, understood? It will give 56% of this and 44% of this. So by changing the ring size, we can see the reactivity of of NaBH4. Now in NaBH4, there are many derivatives of NaBH4. Like lithium borohydride, sodium borohydride, sodium borohydride we have already seen, lithium borohydride, zinc borohydride, ZnBH4 whole 2. Next is sodium NaBH3Cn. Okay, next one is sodium BHOAC whole 3. Okay, next one is Luce reagent, and it is very most important. In Luce reagent, and the last one is L or K selectride. L or K selectride. Now what is Luce reagent? Luce reagent is nothing but sodium borohydride using with selenium trichloride and 7H2. Okay, now Luce reagent is basically used for used for reducing alpha beta unsaturated ketone. We'll talk about later. Now tell me what will happen? What will happen? That the OH group, where the OH group attached, A or B, where the OH group attached. Everyone tell me where the OH group will attached, A or B. Where the OH group will attached, A or B. Everyone tell me where the OH group will attached. Sorry, polar solvent first used, then NaBH4, then complete 1,4 reduction, but what you are talking about? What you are talking about? A polar solvent first used, then NaBH4, then complete 1,4 reduction, but in order of reagent reverse, then 1,2 reduction. Yes, good. Yes, you are correct. B, of course, it will be in more substituted, so we'll get CH, we'll get CH3, CH2, here will be OH, and here will be CH3. So this will be the product. Similarly, here will be the OH group attached, because here will no carbocation formed, therefore there will be no rearrangement. Okay, so there will be no carbocation formed, so there will be no rearrangement. Similarly, here will be carbonyl OH group attached. Okay, so we'll get CH3. So if the CH3 group in the above position, the OH group in the below position. OH group in the below position. Okay, so next tell me what will happen. In this case, the sodium borohydride will attack and will get alcohol. We'll get alcohol in it. Similarly, for this we'll get alcohol in it, and similarly for this we'll get alcohol in it. Okay, next one. See, we are talking about Luce reagent. Okay, we are talking about Luce reagent. Now Luce reagent is using CCl3 selenium trichloride with cerium trichloride with sodium borohydride, and it will make in presence of, yes, all three alcohol. It will make in presence of this is HCCl2. HCCl2. Okay, now what happened? Now if we are using alpha beta unsaturated ketone in presence of HCCl2, so at first what happened, this hydrogen will come into this and the oxygen will attack to selenium. So here it will be not the hydride came from, not from the hydride not came from sodium borohydride directly. The element or the metal we are using, that is selenium. Okay, the metal we are using here, that is selenium. So this will form, after H plus, after giving H plus of protonation over workup, we will get this product. After using H plus or protonation over workup, we will get this product. Okay, now see one thing. This one. Okay, this one. Okay, so everyone see that in using this alpha beta unsaturated ketone, so the solvent is methanol. When you are using sodium borohydride, it will give 100% of this, 100% of this product. But when we are using sodium borohydride with CCl3, it will give 100% of this. So it is a very good tool, or it is a very good reagent to selectively reduce alpha beta unsaturated ketone in its carbonyl position. Okay, so it will selectively reduce alpha beta unsaturated ketone in its carbonyl position. Okay, so hope you understand this. Okay, so when 6-membered ring, see, this is very most important. When we use 6-membered ring alpha beta unsaturated ketone, 6-membered alpha beta unsaturated ketone. So it will give 59% of this and 41% of this. But using CaCl3,7H2O, it will give 99% of this alpha beta unsaturated ketone in the 1,2 position reduction. Okay, and but only 1% of this complete reduction. Okay, 1% of this complete reduction. Now one more thing. Now we have to go for one more thing, that the reactivity of Luce reagent. Reactivity of Luce reagent. What happened? Now reactivity for taking reactivity of Luce reagent, it will reduce alpha beta unsaturated ketone first, then it will go for ketone, and then it will go for aldehyde. Okay, so it will go for alpha beta unsaturated ketone, then it will go for ketone, and then it will go for aldehyde. Understood? So so when a compound have alpha beta unsaturated ketone and a aldehyde and an aldehyde, so it will reduce alpha beta unsaturated ketone instead of aldehyde. So this will be the product. Okay, this will be the product. Similarly, so here is the difference between lithium aluminum hydride and sodium borohydride. That is, it can sodium borohydride, it cannot reduce ester. Okay, so it will reduce only aldehyde. But for lithium aluminum hydride, it can reduce both. So both are reduced to alcohol. Okay, so here is the chart. That I have already told you the reactivity order, that by sodium borohydride, it can reduce only this and not reduce this. But lithium borohydride can reduce everyone. Okay, can reduce everyone. Every carbonyl group. Okay, so let's go further. So before starting questions of sodium borohydride, okay, I'm telling you everyone that if you are looking for June 2024 examination, as you all know, the scorecard has been published of CSIR NET 2023 December examination. So so if you are looking for June 2024, you can go over to our website. There are such a thing is all are in free access. You get free access of paper analysis of last 12 years as well as 5-year exam cutoff, last 12 years previous year question PYQs, as well as with its solutions, and as well as you can get the last examination like 2023 December examination PYQ with its solution. Okay, and exam related all the information you will get in our website. Just go and log into our website and check all the freely available things in our website. Okay, there is a portion like learn free section. You can go to there and check all the things. Okay, check all the things. Okay, see our first question today. Let's go everyone. I am starting timer. Login. Okay, after login there will be no OTP. Okay, I'll talk about them. After login there will be no OTP. So if you are login, see Mohammed, if you are login once, okay, there if you are put OTP once, okay, so then if you are log out, if you go for log out, okay, so you must take 4 to 5 minutes to for again login. Okay, for next login you must take 4 to 5 minutes. Okay, if there is no, I will talk to the technical team. Okay, tell me what will be the product of this particular question. Tejas is C. Third piece is 4. Everyone answer please. Everyone please answer this. Everyone please answer this. Keep liking this live and share to your friends. You have only 30 seconds. Faster, answer faster. Answer faster. A. Is it A? Is it A? Just look it clearly and tell, is it A or not? Is it A? Okay, the timer is stopped. Timer has been stopped. Timer has been stopped and we'll go for the answer. Okay, let's see. See, here sodium borohydride is given, and the product in the reactant, what is this? This is ester, so it cannot be reduced. What is this? This is ester, it cannot be reduced. So simply the thing is simple, very simple, that the the ester would not reduce. So this three option is incorrect. This three option is incorrect. The correct option is 1. So the correct option is 1. So see, if the ester is not reduced, so what will it reduce? So there is 2 carbonyl group here and here. Now this carbonyl group is for amide. Sodium borohydride is not for amide reduction. Okay, you remember, sodium borohydride is not for amide reduction. So therefore it will go for only keto reduction and it will get this. So correct answer is option 1. Okay, Manisha. Okay, Tejaswini. So everyone, correct option is option 1. Okay, let's go again. Next question. That the following transformation is achieved via. See, the following transformation is achieved via which reagent? So the timer is started. You can answer it. Timer has been started. You can answer it as fast as you can. Everyone answer it. Everyone answer. See in the reaction what happened. Just see in the reaction what happened. Okay. 1 1 3. Check it again. Check it again. 1 1 3 1. Okay, check it again. Check it again. Please check it again and tell me. See in the reaction what happened. What just happened? You have 1 minute. Everyone just answer it. You have 1 minute. And keep sharing this live with your friends. And like this live. Okay, only 30 seconds left. Only 30 seconds left. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So no answer. 1 and 3. No another answer. Okay. See what happened here. What happened here? There is ester and there is acid. There is ester and there is acid. Okay. So NaBH4 will not reduce it. NaBH4 will not reduce it. Now coming for lithium aluminium hydride. Now coming for lithium aluminium hydride. Lithium aluminium hydride will reduce both. Will reduce both. But only and only which one is reduced? That is acid one. The acid is reduced. Okay. Only and only the acid is reduced. Now you tell me, what is the reactivity order? What is the reactivity order? We know that ester is much more reactive. Ester is much more reactive than acid. Ester is much more reactive than acid. So ester is much more reactive, but acid is reduced. Ester is more reactive, but acid is reduced. So what it will happen? So see, here the reagent we are using, that is BH3. BH3 is a BH3 is a we can say that is a electrophilic hydride transfer reagent. Electrophilic hydride transfer reagent. Okay, so basically I am this example is for that you have to know how to remove your options from the question. Like we see that sodium borohydride, it cannot done we cannot done with sodium borohydride, we cannot done with lithium borohydride, lithium aluminum hydride, it cannot be done with borohydride, like any borohydride, lithium borohydride, or so like any borohydride, it cannot be done with that. So these options are incorrect. So option 3 is correct. Okay, if you are not you have not you are not fond of BH3, okay, or any Lewis acid. So in presence of Lewis acid, BH3, it will reduce acid instead of ester. Okay, it will reduce acid instead of ester. So correct answer is option 3. Next, before going to further question, so we already have started our live batch. Okay, so if you are looking for any live batch for guidance of your 2024 June examination, or any JRF examination, if you are looking for JRF, okay, so you can come to here and purchase our live batch. You can join our live batch. It is not a recorded batch. You can go for our live batch. All the perks you will get, like every live batch recording you will get, DPPs and like mock test, full test series, and as well as many more things. Okay, not only the live batch, okay, not only the live class, many more things you will get by purchasing this. So the live batch started already from 29 Jan, but the offer is still on. 75% off is still on. You can come to our website and you use IFAS 75. Okay, if you have to use IFAS 75 to enroll this offer. Okay, let's start next question. Let's go for the next question. Following transformation is achieved via this transformation. Let's say who will go for the correct answer? Following transformation will be achieved via which reaction? Four. Is it 4? Just look at once. Is it 4? Just look at once. Yeah, good morning everyone. Is it 4? See what happened. We have to see the question, then going for answer. See what happened. See, here is a ketone group. Okay, so it is I think already have done. Okay, whatever. So here is a ketone group. So there is amide and there is ester and there is amide. So this will be not reduced. Okay, this is not reduced in the product. Only the ketone is reduced. So we can go for sodium borohydride. Okay. Next question. Tell me the major product obtained in the following transformation is. Yes, every people. Yeah, the correct answer is 4. The major product obtained in the following transformation is. Tell me which reagent we are using. This is a name reagent. The reagent has a name. Which reagent we are using? Luce reagent. Very good. It is Luce reagent. So what will be the product? 45, 1 Luce reagent. Okay. So what will be the product? What will be the product? A. See, I told you that Luce reagent, the reactivity order is alpha beta unsaturated ketone and then ketone and then aldehyde. It cannot reduce ester. So whenever the ester reduce, so option 2 and 4 is incorrect. Option 2 and 4 is incorrect. Now in presence of aldehyde, it will reduce. In presence of aldehyde, it will reduce what? In presence of aldehyde, it will reduce ketone. So correct option will be option 1. So correct option will be option 1. Okay. So the last question we are doing today. So I am telling this question you are not fond of if you are. So in presence of ZnBH4, what happened? So Luce reagent, the reactivity order was this. Luce reagent, the reactivity order was this for Luce reagent. Now for ZnBH4 it will be different. For ZnBH4 the reactivity order is this. Okay. So H minus. So the methyl group is from above side. So the H minus will attack from the below side. Okay. So we'll get the product C. So correct option will be option C. Okay. Everyone understood? So correct option will be option C. Okay. So many of you had been attempted this last examination of CSIR. Okay. CSIR December 2023. So the scorecard is already been published. Okay. The scorecard has already been published. Okay. So if you want to know your rank, okay, if you want to know your rank, what will be the rank in lectureship or what will be the rank in your JRF. You are qualifying JRF or you are qualifying lectureship, you can go to our website or you can go in the link in the description of blank predictor. Okay, you go for the rank predictor section and you can predict your rank by it. Okay, so go fast. Hydroboration is oxidation is possible. Hydroboration oxidation is possible by sodium borohydride. Okay, in the hydroboration oxidation, no. Oxymercuration, demercuration is possible, not hydroboration oxidation. Okay, so this one you can join our ifasonline.com. There is 1,000 plus of selection in chemistry, so you can join there. Okay, so now we are closing this class for today. Thank you everyone. Thank you for today. Okay. No, in ZnBH4 hydroboration oxidation is not possible. Okay, thank you.